In this slidecast, we're going to talk about abstract data types, interfaces, and pre- and post conditions. So an abstract data type, it encapsulates data and methods. Its primary purpose is for generating reusable code. Now the significant thing is that a user doesn't need to know about the implementation of the ADT. Instead, the user only interacts with the ADT using the public methods. So C++ classes provide one way that we can implement ADTs. So the public functions control access to the private data fields and determine the manner in which the data is manipulated. So one of the primary goals this semester is for you to learn how to write and use ADTs in programming. In fact, this is a data structures course, and all of the data structures we're going to talk about are common important data structures in computer science, and they can all be built using this concept of an ADT. So as you build ADT implementations this semester, then you can create pieces of reusable software that some you'll be able to use in later programming labs. You might be able to use them in your coursework in the future, and they might just be useful to you when you build any kind of software project. Now the C++ has a standard library that has a nice collection of ADT implementations, including these significant data structures that we will discuss this semester. So an important part of the class is there's two parts. You're going to learn about the existing ADTs that C++ provides, and you'll learn how to select the right one to use and when you might want to use it. And you're also going to gain experience implementing your own ADT. When you move to other programming languages in the future, I want you to be prepared that you can recognize in its library some of these common important data structures in C++ and how you might want to use them. So the public part of the class definition specifies an ADT. And the specification is it's the function signature that you're already familiar with. So a function has a name, it has parameters, those parameters have names, and it has a return value. And this function signature, it specifies what the function does, but it doesn't necessarily inform you or dictate how the function is implemented. Okay, so this public part of the class is referred to as the interface for the class. So classes that declare data fields and they have code that performs these operations, we say that that class implements the ADT. Now, an ADT can often be implemented in more than one way. For instance, there might be a slow way to do an operation that's easy to build, and there might be a very fast way to do it that's much more complicated. And there might be cases when we want to build it one way or another. So we can have more than one class can implement an ADT. But each class that does implement the ADT, it has to conform to the complete definition and implement all of the operations that were originally declared in the ADT. So the telephone directory class from in Chapter 1 is an example of an ADT. And in this chart, on the left-hand side, we see the 5 public operations or functions that are defined for this ADT. And these are function method signatures. Each includes the name of the method, parameters, and the return type. So for instance, let's look at the second row in this table. We have a lookup entry method. It has one parameter. The name of the parameter is name. The type of that parameter is a const string. And notice the ampersand. That indicates that this is a reference parameter. So we'll be using call by reference when this function is called. And that means a pointer to the name string is passed to this function rather than a copy of the name string. Okay, remember the copy is call by value. Now remember, a call by reference by itself means that if the function makes any changes to name, it's reflected back into the variable of the caller. But this keyword const in this case means that the name that's passed in can't be changed. And the return value from this lookup entry function is a string. And if we look at the behavior, this function looks up an entry in the directory. If the entry doesn't exist for the given name, then it returns the empty string. So that behavior, that describes what the function does, but it doesn't say how it performs it. How is that lookup process take place? Again, there might be many ways we could do it. So there's a contract between the ADT designer, whoever comes up with the function signatures, and then the programmer who implements that class. And then any programmer who uses the class, okay, in the second bullet, that's a different programmer than the programmer in the first bullet. We're talking about two different programmers. So let's be clear. I'd like to make sure you clearly understand that. The programmer in bullet point 1 is the programmer who implements the methods. So we back up one slide. The programmer who provides the implementation for the lookup entry routine. Now in the second bullet point, this is a programmer who makes use of the class. So this is a programmer who's writing some other class and wants to invoke the lookup entry method. So that programmer who uses this class, has to know what functions are available and what operations they will perform, meaning they really need to know the details of what's in this chart, but they don't need to know the details about how the programmer actually built the lookup entry routine. So those programmers, don't need to coordinate. Okay, that interface kind of provides a contract so that they can both work independently, and as long as they adhere to that well-defined interface, then the system should work. And this illustrates the utility of using abstraction and abstract data types, is that programmers can work independently, and adherence to the interface means that our system should work when it's completed. Okay, finally, let's talk about preconditions and postconditions. They're part of the contract between the programmer that's calling the function and the programmer that implements the function. Now, the precondition is a statement of any assumptions or constraints on those input parameters. Any assumptions that the programmer who implemented the function is assuming apply to the input parameters. And if the precondition isn't met, then the function is not guaranteed to perform as expected. Now, a postcondition is a statement that describes the result of performing an operation. And when we implement an ADT, we document these preconditions and postconditions in the comments. Now, we don't need to do this for every function. We'll use them judiciously, but we will document this information when it's not readily apparent from the normal information that's in a function signature. So as a general rule, we want a postcondition for operations that have a void return type that makes some change to an object state. Okay, so when we have reference parameters and a function can change state, we call this a side effect. Then we need to document that so that the caller of the function is well aware of what state changes can take place. Now, if a function returns a value, then often we can describe the postcondition in the @return tag. Now, I'm assuming you're familiar with the @return tag. There's a common set of tags that tools that produce documentation from source code rely on to do a pretty formatting. Maybe they can highlight certain keywords. So @return describes the return value from a function. Now here is a small method for a bank account class, and it's a process deposit method. And in the comments before the function, we have a pre and post to document the precondition and the postcondition. So this method has a single parameter called amount. It's of type double. And the precondition is that the amount is positive. We can only deposit positive amounts of cash into our bank account. Okay, so the assumption is that amount is a positive number. Now, I might state, maybe it's got to be greater than 0. The post condition is that the function adds the specified amount to the balance. So we'll assume there's a balance private data field for this class, and the implementation is simply balance equals balance plus amount. So there's an example. Now, pre and post, these are not keywords that the documentation tools typically understand. These are just the kind of the convention that the textbook author is illustrating. One thing I might mention, in a real implementation of such a method, you can document these preconditions, but I think it's good practice for the code, to verify these assumptions. So in this case, the function could check whether the amount is indeed a positive number, and then throw an exception, maybe generate an error message when that assumption is violated, rather than just trusting or leaving it to the user of the function to adhere to the precondition. And that's it for this Slidecast. I'll see you in the next one.